Okay, so we are going to be solving exponential equations. And there's going to be two different ways that we do this. This video is the first way. The second video will be the other way. So with this video, what we're going to be doing is solving exponential equations that have the same base. So we're going to do two examples. Here's going to be example number 1. And we've got 3 to the 4x plus 1, and that is going to equal 3 to the 2x minus 5. All right, so what we're looking for in order to use this kind of method is we need to have the same base. So these are exponential. They have bases, they have exponents. My base is clearly the same here. They're both 3. So if you get a problem like this, same base, right away, I can just set my exponents equal to each other. So if you have the same base, those are the nicest kind of problems. Set my exponent equal to each other, and then I can just solve for x. So this is a multi-step equation. I like to get all my x's on the same side first, and I like to keep them positive, but that's just me. Your first step could be different than mine. Okay, so now my x's are all on one side, and now I need to get my constants, or like the numbers, to the other side, away from the x. So I'm going to subtract 1, because that's going to undo this side, and what I do to one side, I do to the other. So I'm left with 2x equals negative 6. And now I need to solve for x by dividing both sides by 2. And again, the reason I'm dividing by 2 is because this is currently being multiplied, and that's how I'm going to undo it. So my answer is x equals negative 3. So this is the solution to my problem. So you might be asked to solve an exponential equation or find the solution. This is my solution. Okay, so that was a nice one because my like bases were very obvious. They were literally the same number. Sometimes you have to do a little bit of thinking and an extra step in there before you can see the like bases. So let's say I've got a problem like 2 to the x minus 5 equals 8 to the x minus 9. Okay, if I'm looking at this, it's not readily apparent that they're the same base because really I have a 2 and an 8. They're not literally the same base. But what I can do with this 8 is that I can rewrite it with a base of 2 because 2 to the third power is the same thing as 8. How do I know that? Well, I could check if 2 goes into the other number, and I could check different exponents. 2 squared is 4, so that's not it. 2 cubed is 8, so that works for me. We're not going to go that far into this, so the problems you're going to do are pretty obvious. You're going to have like a 5 and a 25, or a 6 and a 36. So they're going to be pretty low exponents. I think they're pretty easily, clearly related in some way. So what I need to do is I've still got 2 to the x minus 5 on this side, but instead of that 8, I've got 2 to the third power because the 8 is what's being replaced. Now, the rest of the equation is still there, that x minus 9, but I'm going to put it in parentheses because this 3 is going to be multiplied by this entire part here. Okay, now I have those like bases that I was looking for. Now I have 2's. And the like base itself doesn't matter as long as they are the same. I can now set my equation, my exponents equal to each other. So here I go. I've got x minus 5 on the left, and I've got 3 times x minus 9 on the right. And this is a multi-step equation. I'm going to have to distribute and get rid of that 3 first. So I have x minus 5, and then I have 3x minus 27. Okay, again, I want to get all my x's to one side first. I like to have them positive, so I'm going to move this x to the other side. So I have negative 5 on the left, don't lose that sign, and I have 2x minus 27 over here. All right, now I have a two-step equation left over. I'm going to get all my constants on one side. That means I need to move this by adding 27 to both sides. And the reason I added is because it was being subtracted. That eliminates it from that side. Negative 5 plus 27 is 22. and that equals 2x. So my last step is to divide both sides by 2. And I'm left with just x by itself, and 22 divided by 2 is 11. So that is my solution. So to recap, look for like bases. You need like bases. If they're there, great, set the exponents equal to each other. If they're not there, see if one of the numbers is a factor of the other. And then you can rewrite it with that base, and then you can set the exponents equal to each other.